And I'm actually going to multiply this 1/8 by, what are you saying I should multiply by? 5 on the bottom and the top, right? Now, you're telling me 5 over 5, right? Isn't that just 1 though? Right? Isn't anything over itself 1? But see, that's the whole key. Don't write this down. If you take anything and multiply it by 1, has it changed? No. But the way we're choosing to put a 1 here, by putting 5 over 5, we're actually being clever, and we're rewriting the 1/8 fraction in a different form so that it still is 1/8, but it just looks different. Instead of being 1/8, this is going to become 5/40ths. Now I have to do the same thing on this one. What do I multiply by here? 8 over 8, right? Which again is 1, which doesn't change the answer to the problem. So you get on top 16, on the bottom 40. Now we have the same denominators. And once you have the same denominators, all you have to do is go across the top, whatever this operation is. So 5 plus 16, which is 21 over 40. What's the difference between addition and subtraction? Like if I were to change this problem right now, if I were to make this a minus, then this would be a minus, right? And then this would be a minus. And then instead of doing 5 plus 16, you would do 5 minus 16. What is 5 minus 16? Uh-oh, negative numbers, right? Negative 9. Over 40 again. Do y'all see the difference between those two? I do expect that everyone here is comfortable with signed numbers. Like you can do 4, take away 13, and not need your calculator for that. So it might take a little while to get your brains going again if you haven't been doing that in a while, but you understand what I'm saying? Like, let me just show you. Like negative 3 plus 7, negative 3 plus negative 7, negative 3 minus negative 7, negative 3 minus 7. Here, let's just quick quiz on that right there. Not quiz, like just mental quiz. You ready? 4. Negative 10. 4 again. Negative 10. Okay? 4, negative 10, 4, negative 10. So if you don't have those, if that's not working for you, again, just put an asterisk, you know. Just be like, I need to go back and look at some signed numbers then or something. And that would be where you either come and see me or you go across tutoring lab and say, hey, my instructor was showing me this. Like, I'm confused, and they'll help you get up to speed on that, all right? You want to try number 2? Okay. Try number 2, which is 7. It's a mixed number, 7 3/5 minus a half. If you've got it, just show me your hand real quick so I can see where people are. All right. Does that look right? That's what this little thing is telling me the answer should be, but everyone needs to like make sure they silence their phones, okay? Anyone not getting 41 over 10, like something's up maybe? Okay, this key could be wrong. I started to review the key and I found an error on the first answer and I was like, I'm not going to go through this whole thing, you know. All right, so let's see here. What do you do first? Turn it into an improper fraction. This one right here. So 7 times 5, 35 plus 3, 38, and then put that over 5. And then minus the 1 over 2. Now you're subtracting two fractions. You must have the same denominator.
It's 3 1/2.
Where?
2. Yeah, the number 2. This is different on this one.
Is it different on there? On what? The handout packet? Really? Okay. That's not good. Really? Okay. Oh man, don't tell me that. All right, let's see what happens here. Let's just go off of whatever problem I'm doing on the board is the problem that we're going to do. All right. What's the common denominator? 10. So I'm going to have to really like multiply this guy over here by what on top and bottom? 2, 2, and then over here 5 and 5. So I'm going to do that little multiplication on each one of those first and then see what happens. So 2 times 38, 76 over 10. So this equals 76 over 10 minus, and then over here 5 over 10, which gives you 71 over 10. Yeah, I should probably just throw that away. It's good, good. You're nervous. I'm glad. It's okay. Look, we'll all be okay. If you're doing some homework problems that are a little different than your classmates, it's okay. All the concepts are going to be the same here. So, all right, let's try one of these word problems, because I know that's probably your favorite thing. And I would hate to not allow you to have some fun today. Now I was sitting here, I was thinking while you were working on that problem on your own there, I was thinking like trying to go back and see if I could get inside your head a little bit while you're sitting here doing this arithmetic. And you got to like be asking yourself, especially the people who hate math, and I know there's a few people in here that told me they did. I think part of it is the fact that you don't really see any use for it. Or maybe I'm wrong. And the thing is, I will agree with you completely. And here's the thing, like, you got to look at all the math we're doing right now is the same as me walking in here with a hammer and a nail and saying, okay, we're going to put this nail into this piece of wood. All right, how many of you know how to put a nail into a piece of wood? All right, okay. Now, how many of you have ever used a Sawzall? Yeah? How many of you have never used a Sawzall? All right, so I'd have to maybe show you how to use a Sawzall, but it's just a tool. How many of you have ever done like MIG welding? Few? Everyone else never done it? I would have to teach you how to use that, right? All of those tools are used for something, aren't they? You could build a house, build whatever. Everything we do in here, all this algebra is tools that we use to do more advanced things. And unfortunately, because this is the end of the road for you, not unfortunately, I guess you don't want to do anymore, that's fine, but engineers need these tools. They need to be able to use these things to build bigger things, right? Your phone, satellites floating around, cars that are smart, you know, all these things are pushed further and further by engineers. And these engineers have to be able to think a certain way, right? The way an engineer thinks. These are the tools they use. So it's kind of like when I was writing that paper on, that 37-page paper I had to turn in on some obscure culture, you know, and I'm sitting there going, kidding me? Like, no, I think I was typing it. You know, I'm like, do I really need this? Okay, well, somebody who's going to be in that field is going to need that. So why do I need it, right? Why do you need this? Why do you need this at all? Do we have an answer to that? No? You need this for your degree, right? You're never going to be, I doubt you're going to be adding fractions to, ever, right? And I doubt you're going to be talking about Dolores who sold some candy by the pound, right? In some candy store, right? So why do this? I don't know, man. Maybe we should just leave. Everyone come back August 11. We'll just, you know. No? Why are we doing this? Really? I'm asking you a serious question, right? Anyone have any answer?
I will be doing this, but not.
Not Dolores and her pounds of candy?
Oh, no, that'll, I'll be a teacher.
Okay, well, if you're teaching it, yeah, that's a little different. Okay, so I'm going to give you an answer. It's kind of a loaded question. I'm giving you my answer, all right? I have two answers. First answer is that you are a little circus animal, and you are jumping through hoops, and at the end, they're going to give you a piece of paper, and that piece of paper is going to allow you to do whatever it is that you want to do. And one of those hoops is a math class. And there's a bunch of other hoops. Some of them are interesting to you, some of them aren't. Right? That's one perspective on it. But there's something valuable in this. And that's the person who has that piece of paper, when they're going for a job, that piece of paper shows that that person is teachable. All right? You can learn. So if I have a position, I have someone who doesn't have that piece of paper versus somebody who does, what I can tell you is that that person can learn various skills even if they don't like them or they don't excel in them. They have a rounded education. They can do various things. Understand? Now, that doesn't mean that's going to be a better employee, right? That doesn't mean anything really. But it gives that assurance, right? That little bit of assurance that that person can learn. Got it? Okay. So that's part of why we're having to learn this. The other part of it is just the fact that people are so different. And like, what's beautiful to you and what's beautiful to me are different things, right? And there are some people that find this very, very beautiful and very rewarding. And you're just getting a little glimpse into it. And if you don't like it, you don't like it. Just like I didn't like reading about cultures I didn't like. Right? But I did learn a little something about it, and I learned to have some respect for it. And that's part of what education is about. All right? Okay, sorry. Let's talk about Dolores and her candy store, because I think that's, you just want to know what you're going to need to do? So the most important thing on word problem is to turn the word problem into a mathematical problem. And it should match up pretty well with what we've just done. Dolores sold candy by the pound. The first person came into her store, bought, and see, this is already bad notation, but this is what they mean. 2 1/4 pounds of gumdrops. The second person who came into the store bought 5 3/4 pounds, 3/4, of jelly beans. These people are buying a lot of candy, right? That's a lot of candy. How many pounds of candy did Dolores sell to her first 2 customers? So what do we want to do? Add those 2 together, right? And that's it. I'm not going to go through the work, okay? I'm going to say ... because that you would convert those to improper fractions, just do what we've been doing, right? Okay, what about the next one? Language arts class. The class was assigned to write a team paper. Each team was to write 5.5 pages for the combined paper. When all teams put their papers together, there were a total of 44 pages. How many teams had worked on this paper? So how are you getting that?
5 times
Okay. So you're doing just a mental calculation. Let's see if we can turn it into something we've done here today.
44 divided by 5.5.
So the paper was 44, right? And you wanted to divide that into groups. Each group did 5.5 pages. So if you take your 44 pages and divide it by the number of pages, which was 5.5, then that would be the computation right there. Again, ... meaning I'm not going to do that. I will give you one hint. The 44 is going to need to be turned into 44 over 1. And then you do this one to your improper, and then flip, multiply, and you should be there. Questions on what you would do with that? Any questions on the interpretation of the problem? How about Dennis and his dog? What? 127 3/4 pounds. It's a little chihuahua, I guess. The dog weighs 127 3/4 pounds. His friend's dog weighs 97.5 pounds. How much more does Dennis's dog weigh than his friend's? So what is the operation you're going to do there? Subtraction. Which one is subtracted from which? 94.5 is taken away from the 127. So you write it this way: 127 3/4 minus 94 1/2, and that should give you the difference in their weights. Both of those have to be turned into improper fractions, and then so on and so forth. Okay, that's all I'm going to do for that. Let's move on to the next section. Order of operations. All right, so order of operations. I will review this quickly. Because this is important. I'm going to put something on the board here, and we're going to take a poll, and we're going to see what we get. So everyone, I want you to compute this for me. Another way I could have written that is like this. That's the same thing, using a slash instead of the division symbol. I want you to do 12 divided by 4 times 3. Everybody there? Everybody have an idea? Okay, so I'm not going to hold this against you at all if you get this wrong. Anybody want to tell me what they got? What? 1 is, okay, that's a very common answer. That's a 1. And yeah, the other one I always hear is 9. 1 and 9. Anyone get something else? Okay. You should get 1 or 9, all right? So should we do a hand vote for this? Do you want to know? Okay, let's see. 1s. Up high. Okay. 9s. It's all right if you think it's 9s. Okay. All right, so we're going to have some people learn something today for sure. All right. So for those of you who said 1, how'd you do it? You multiplied what, these two first and got 12. And then you did 12 divided by 12 and got 1, right? Okay. Raise your hands again. All my 1s? Whew. Okay. Now my 9s. There were only a few. Where were they? You obviously screwed something up, right? What did you do?
Divide first.
Okay, well, wait a minute. Why did you divide first? You're right, okay? You're correct. But why did you do it?
That's the order of operations.
That's the order of operations, but all these other people did it the other way. You got to feel like you're wrong, right? How could this many people be wrong about 1? Anyone else have? Whoever else got 9, what's your...
I just, when it came to like the PEMDAS thing,
Yeah.
I mean, add still comes before subtract and multiply still comes before divide, like in the word. So I think that's always screwing some people up.
That's right, and that's why I want to talk about it today. Because the correct answer here is 9. All right? Let me explain why. It's probably one of 2 things. You either learned it incorrectly, meaning it was taught incorrectly, or it was taught correctly but you weren't paying attention. It was one of those 2 things. How many of you have ever seen this? PEMDAS. Now there's all these little cute acronyms for this, right? Anyone have one of the acronyms?
Please excuse my dear Aunt Sally.
That's the one I learned too. Please excuse my dear Aunt Sally. All right? Anyone learn a different one? Okay, so we all excused Aunt Sally, yes? Okay, so this meant you always do what first? Parentheses, then exponents, multiply, divide, add, subtract. And that's cute, but it's obviously not working correctly. And the reason is because multiplication, division, and addition and subtraction are not done multiplication before division or division before multiplication. It's always whichever appears first as you read it from left to right like a book. So this is always in order of left to right. It is never, ever multiplication before division always. That is, throw it out, okay? That's not correct. Addition and subtraction, same exact thing, left to right. Now, I'm with you, okay? I'm one of those people that would have done this and got 1, okay? Somehow I got through my high school math and just, I learned it wrong or something happened, okay? The connection was never there. But I'm here to try and steer the ship straight for you, just like someone did for me. These are equally weighted, all right? So when you read this, you don't have parentheses, do you? You don't have any exponents. Exponents are powers, right? Powers on these numbers, you don't have those. So you come to multiplication, division. So you look for multiplication, division. Do you have them? Yes, I have both of them. Which do you do first? Read it from left to right. So this is first, 3. Now you do your multiplication, and you get 9. Now it's critical that that works. So if you have your calculator, if you happen to have it, I just want you to type in 12 divided by 4 times 3 on your calculator. Just do it real quick. And what does it say? 9? Because your calculator knows the correct order of operations. It's programmed in, it will do it correctly. All right? So a lot of people learned something today. You can't say you learned nothing, right? You learned something? All right. All right, so we're going to use this order of operations now, and we're going to do some simplification of some expressions. Let's see how this goes. For simplification, at your own risk. All right? Because here's the thing with the calculators. If you do it on your calculator and get it wrong, and you just have an answer that's wrong, I'm going to take everything off. If you show me your work while I'm grading your exams, because all your exams are going to be written exams. They're not going to be multiple choice. And so as I'm working through and looking at your work, I'm going to be looking for partial credit. I want to give you credit. You're demonstrating you know what you're doing. If you just have a wrong answer because you were just punching away on their calculator, it's wrong. If it's a 10-point problem, it's minus 10. So at your own risk, it means you got to be comfortable with all the parentheses and all that on you got to be real comfortable with it. So let me do number 1 on my page. I don't know what yours is going to look like, but 5 minus 3 plus 72 parenthesis 10 minus 2. Man, we only have 20 minutes left. I won't yap as much next time. I'll just be strictly business here. All right, do you see parentheses? Yes? So that means your entire universe becomes just what's in there. And now you start over. Do you have any parentheses in there? Inside there, do you? No? Exponents? No? Multiplication? Division? Addition or subtraction? Yes, so 10 minus 2 is 8. Okay, so I'm going to replace that with an 8. Now watch the way I'm writing this, because this is kind of like an English class in the sense that when I was taking that English class I didn't like, I had to use proper punctuation, and I had to put periods at the end of my sentences, and I had to do basic stuff. I would like to see basic mathematical handwriting that's decent, all right? Doesn't have to be top-notch stuff, but I need to be able to follow your train of thought. So I'm going to go from this line to the next line, and I'm going to replace this 10 minus 2 with 8, right? So let me just put an 8 there. Now, what is the operation that's occurring between the 72 and the 8? Multiplication. So I'm going to have to put a dot there. You could leave it in a parenthesis, like this, but then you just need to know that that's multiplication, right? So either way. Did I see another hand? Yes? Okay, yes, you could leave it in parentheses. But as long as you know it's multiplication, you could even do that if you wanted to. That's fine. Okay, start over. Do you see anything in parentheses? Well, if you wrote parentheses, you would, but there's nothing you can do with 8. It's just there. Exponents? No. Multiplication or division? Yes. Multiplication right there. Got to do that now. 72 times 8. 5 minus 3 plus. What is 72 times 8?
576.
576. Now you could use your calculator for that if you needed to. Okay, start over. Parentheses? No. Exponents? No. Multiplication? No. Division? No. Addition or subtraction? Yes. Which one first? In this case, we're going to do this first. Right? Left to right. So 5 take away 3. 2. 2 plus 576 is 578. And we are done. Okay? Let's try one that's a little more interesting. 2 plus 2 times 3 minus 6 minus 1 plus 1 minus 4 squared squared. And I know you're sitting there going, oh my gosh, that's just ridiculous. Trust me when I tell you that an engineer will face something like that. Someone taking higher math class will see that, and they will have to deal with it, and they will not be afraid of it, and then they'll move on, okay? Unfortunately, like I told you, you're just looking at the tools here in this class. Where do you begin? In the parentheses, but I see 3 parentheses. So I see this set of parentheses, right? Inside of that, there's not a parentheses. Over here is another set of parentheses. Inside of that is another set of parentheses. So where do we begin? You try and go as far in as you possibly can, all right? But we do have 2 sets of parentheses that are separated, aren't they? Like these two? So I can do this one, and I can do this in here. Or I can do them separately. It doesn't matter. So how about this? I'm going to write equals. I'm just going to go 2 plus 2. Let me go ahead and take care of this. What's 3 take away 6? Negative 3. So I'm going to put negative 3. And let me go ahead and put that in parentheses. Now this is real important that you put that one in parentheses, because you're going to about to multiply it. What if you forget to put the multiplication there? What if you don't write a parenthesis? What are you going to think that is now? You're going to think that's subtracting 3. But this has actually become 2 times negative 3. Over here we have minus, parenthesis, 1 plus. Now what's going on in here? What do we get?
Negative 3 squared.
Negative 3 squared, like that. Put this in parentheses again, because it's negative 3 squared. Everyone okay with that? This and this. Okay, see, I'm not trying to bite off more than I can chew here. I'm just kind of slowly chipping away at this, line by line, moving down. The danger that people get into is that they try and do like 5 steps at one time, and then something goes off the tracks, and you can never really recover from that. Okay, so now I do have another set of parentheses here that I need to work on. Inside of that, I have exponent, don't I? This, exponent. What is negative 3 squared? 9. Side note here, is there even a difference between these two? Like, if I don't have a parentheses around this, like, is there a difference between these two answers? Yes, there is a difference. This means negative 3 times negative 3. What happens when you multiply two negatives together? You get a positive. This means, believe it or not, negative 1 times 3 squared. That's what that means. That negative right here is a negative 1 sitting in front of the 3, and it's not being squared. The square is only occurring on the 3. So this is actually negative 9. Parentheses are not just there for fun. They're there because they represent something. See the difference between these two? So this right here is going to be a positive 9. So I write down all this junk again. There, like that. So I've just replaced this with this. Now what? Parentheses. In here, can you put those together? 10, right? So that's going to become 2 plus 2 times negative 3 minus, now this is going to become 10 squared, isn't it? Now this 10 squared, I can leave it in parentheses, or I can take it out. Either way, forget, ignore the negative there, right? This is going to be 100, isn't it? Whether you square 10, right? No matter how you square 10, you're going to get 100. Okay, what's next? Got the parentheses? Exponent, so I'm going to square that. 2 plus 2 times negative 3 minus 100. I'm down to multiplication, addition, and subtraction. So this multiplication, what's 2 times negative 3?